Hi, question number 5. A smooth inclined plane of length 2.5 meters is fixed with one end on the horizontal floor and the other end at a height of 0.7 meters above the floor. Particles P and Q of masses 0.5 and 0.1 kgs respectively are attached to the ends of a light inextensible string which passes over a small smooth pulley fixed at the top of the plane. Particle Q is held at rest on the floor vertically below the pulley. The string is taut and P is at rest on the plane. Q is released and starts to move vertically upwards towards the pulley and P moves down the plane. Find the tension in the string and the magnitude of the acceleration of the particles before Q reaches the pulley. Okay, first of all, let us look at Q. The string, the object is released. Now Q is moving upward. What is causing it to move upward? The tension. And there is its weight, which is 0.1. That's going to try to make the object move downward. It's going to try to resist the motion of going upward. So we got the tension minus the weight of the object, 0.1 g Newton, and that's going to be the net force. And force is equal to mass times acceleration. The mass is 0.1 times the acceleration. So we have T minus 1 is equal to 0.1 A. So this is our first equation. On this side, we have a contact force R. Okay, and the object has a weight here. This is theta. And this angle here is also theta. We're going to try to see the object's going to try to move downward. But the tension here is going to resist the motion. So we have, to get the net force, we need to resolve downward. So resolving downward, this is 0.5 g Newton. So if we have to resolve downward, this doesn't contain the angle here. So we're going to say 0.5 times g times the sine of theta. Okay, and that's going to be equal to mass times the acceleration. So 0.5 times g is 5 times the, then you have to minus, okay, minus the tension. So 5 times the sine of the angle. Sine is opposite over hypotenuse, so 0.7 over 2.5. Minus the tension is equal to 0.5A. You work that out on your calculator. 5 times 0.7, okay, divided by 2.5, got 1.4. So 1.4 minus T is equal to 0.5A. So we're going to try solve these two simultaneously. So we have T minus 1 is equal to 0.1A, and then minus T plus 1.4 is equal to 0.5A. We add up, so these two cancels out. This is going to be 0.4 is equal to 0.6A, giving the acceleration, magnitude of the acceleration is going to be 0.4 divided by 0.6 is 2 over 3 meters per second per second. We need to find the tension of the string. The tension T is equal to 0.1A, send the 1 on the other side becomes plus, so we got T is equal to 0.1 times 2 over 3 plus 1. 0.1 times 2 over 3 plus 1. So 1.06767. So therefore the tension in the string is 1.073 significant figures. That's the first part of the question. Moving on to the second part. Yes, for the second part, at the instant just before Q reaches the pulley, the string breaks. P continues to move down the plane and reaches the floor with a speed of 2 meters per second. Find the length of the string. So here we are for the second part. Now, the string is broken, Q is here. What is the final velocity here? V. What is V? We want to find V. The reason I want to find V, because this final velocity is going to be the starting velocity of P. P initial velocity will be the final velocity of Q. So here U was 0. We can use V square is equal to U square plus 2AS. What is v square? V square is going to be u square, okay, which is 0 to the square plus 2 times a. A is 2 over 3 as found in the first part times s, okay, and s is 0.7. So v square is equal to 2 times 2 over 3 times 0.7. So that's the final velocity of Q. P starts moving downward. This is the contact force. Force acting downwards, 0.5 G Newton. Theta, and this is theta. So what are we going to do now? It's going to move downwards. So 0.5 G multiplied by the sine of theta is equal to force multiplied by acceleration. We need to find the acceleration, okay, of the object. Okay, what is the acceleration of the object? Okay, v square. Now what we know is that acceleration is going to be then 0.5 times 10 times 0.7 over 2.5 divided by 0.5. Okay, and so if you work this out in your calculator, you're going to reach 2.8 meters per second per second. So this is the acceleration of the object as it moves downwards. Now we know the acceleration, we know the final velocity. V is equal to 2 meters per second. We know the starting velocity u is equal to the square root of all of that. 2 times 2 over 3 times 0.7. So what can we do? We can use v square is equal to u square plus 2as. Alright, and therefore v square is 4, which is 2 to the square, 4, because the final velocity is 2 meters per second. 4 is equal to u square. U is square root of that, so the square of the square root of that is going to be 2 times 2/3 times 0.7 plus 2as, 2 times 2.8 times s. So 4 is equal to, this is 4 over 3 times 0.7, 4 over 3 times 0.7, 0.9 something, so plus 5.6s. Therefore s is going to be 4 minus 0.9333 and so on, divided by 5.6. So 4 minus the answer divided by 5.6, 0.5746. So therefore s is going to be 0.5746. What is the length of the string? 2.5 minus what we just found. So length of string is going to be 2.5 minus 0.5746, 1.95. Alright, so here we are, question taken from October 2015, Advanced Level Maths, HSC M1.